Hello everyone. Today we are going to see two reactions from the chapter Nucleophilic Aromatic Substitution Reaction. Here we are left with the two reactions. The first reaction among them is Sommelet rearrangement, or it's also called as Sommelet-Hausser rearrangement. And Sommelet-Hausser is the name of the scientist which is given to this reaction or rearrangement. And this is the reaction which involves the rearrangement of benzyl quaternary ammonium salt in presence of alkali metal amide to give benzyl tertiary amide. So in this reaction, a benzyl quaternary ammonium salt, it will undergo some rearrangement to give benzyl tertiary amine as the product. And this reaction takes place in presence of reagent alkali metal amide in presence of liquid ammonia as the solvent. So we will see the reaction. So here there will be a benzyl. So this is benzyl group. Since the reactant is benzyl quaternary ammonium salt, this benzyl, benzene ring with CH2 group, it is called as benzyl group. This will be attached to nitrogen which is bonded to 3 methyl groups, so that totally nitrogen will be bonded to 4 groups, so it will have positive charge here, and this is called as benzyl quaternary ammonium salt because though we have written only positive charge on nitrogen, there will be a counter ion like Cl minus, Br minus, which is not represented here. So totally this is benzyl quaternary, nitrogen bonded to 4 different groups, ammonium because there is positive charge on nitrogen, salt because it will be associated with its counter ion. And this undergoes rearrangement in presence of alkali metal amide. Let me take here sodamide NaNH2 in presence of liquid NH3 as the, or liquid ammonia as the solvent. So you will get a product which is benzyl, write a benzyl group, tertiary amine. That means it must be bonded to nitrogen which is tertiary in nature. So nitrogen, if it is bonded to 3 alkyl groups, it is called as tertiary. So already it is bonded to benzyl group, so it is left with other 2 bonds which is attached to CH3, and no positive charge on nitrogen, because if nitrogen is bonded to 4 different groups, then we have to put positive charge on nitrogen. Since it is tertiary amine, we just write N bonded to 2 CH3 and 1 benzyl group and leave it as it is. So this is called as benzyl tertiary amine. So since it has positive charge on nitrogen here, this is ammonium, and since it is in the form of NR3, it is amine. Now we will see the mechanism. So I'll write this benzyl quaternary ammonium salt like this. I'll open this CH2 group. I'll write one of the hydrogen with open bond, then remaining as it is. So this is our benzyl quaternary ammonium salt. And this benzyl quaternary ammonium salt, it contains a methylenic group. This CH2 group here, it is called as methylenic group, and this carbon, it is called as methylenic carbon, and whatever the hydrogen atoms, both of the hydrogen atoms which are attached to that methylenic carbon, it is called as methylenic hydrogen. So this group is in the benzyl group, this group is methylenic group, that is bond CH2 bond, that is called as methylenic group, and that carbon which is present in methylenic group, it is called as methylenic carbon, and hydrogen atoms which are attached to that methylenic carbon, it is called as methylenic protons. And out of that I have written one proton with the open C bond H. And this methylenic proton is highly acidic. Acidic means it can easily be removed from this structure so that this will become CH minus. For example, in the solution we know that there is NH2 minus ion which is got from sodamide. So this proton of this methylenic carbon atom has a tendency to lose easily like this. So that you will get one structure which is having negative charge on this carbon and remaining thing as it is with the positive charge on nitrogen. Nothing happens to this nitrogen part, only there will be negative charge on carbon due to the removal of this methylenic proton. And this structure, it is called as benzylenic ylide. And now this ylide means ylides are the structures which are containing both negative and positive charge in the same structure. So here there is negative charge on carbon, positive charge on nitrogen. So it is called as ylide. Now it will be present in equilibrium with another form of this ylide which is got like this. So you can understand here. If I write this ylide in this form, CH minus NCH3, I will write it as CH3 bonded to H, CH3, CH3 this. Since there is negative charge on carbon here, it will abstract a proton from methyl group attached to nitrogen so that it will become CH2 minus. So this is another form of that same ylide, or you can call it as second ylide. So it will be CH2 because it will take the proton from here, so it will become CH2 and remaining thing is CH2 minus. This is this CH2 minus, then CH3, CH3. Once again positive charge on nitrogen. So remember, in the ylide structure nothing happens to the positive charge on nitrogen. Only there will be introduction of negative charge to the structure. So this is the first ylide and this is the second ylide. And now this second ylide, it will undergo one rearrangement. It is called as 2, 3. You have to write in a square bracket sigma tropic because there is movement of sigma bond here. 2, 3 sigma tropic rearrangement. So that rearrangement will be like this. See here in this ylide we have a negative charge on this CH2 group. So this will attack here and this will be shifting towards carbon-carbon bond, so it will become double bond, and this positive charge on nitrogen will be neutralized, so that we will get this structure like this. See here, this is CH2 will be attached. Then we have here N, this N bonded to CH3, and this is broken here, it will become CH2. So this is the structure. Now you can do one thing, you have to restore the aromaticity here. So what you will do here, you will just shift the carbon hydrogen bond to this ring so that it will become CH2 minus, and this CH2 minus will take the removed proton from here, and this takes place in presence of NaNH2 and liquid ammonia, which is the medium, so that you will get the product as, this is CH2 bonded to N CH3 bonded to another CH3, and here instead of double CH2 it will become CH3, and this is benzyl tertiary amine. So this is about Sommelet-Hausser rearrangement. So at first there will be benzyl quaternary ammonium salt which is having methylenic proton which is highly acidic, that is removed from the amide ion to give benzylenic ylide, and that is in equilibrium with the second ylide. Ylide is a structure which has both the positive and negative charge, and that second ylide it will undergo 2,3 sigmatropic rearrangement to give the product as benzyl tertiary amine. So whatever the group which was here, it is out of that, it is rearranged and shifted to this position, and this will become CH3. That is the rearrangement here. Thank you.